Hey everybody, Mr. Barry here. We're going to have a problem where we have all three types of forms of quadratic functions. We have standard form, intercept form, and vertex form, and that's given to us in this problem. And trying to pick out when we would use each of the functions and why we would use them in each scenario. So let me go ahead and read the problem. It's right here in front of you. Jason jumped off a boat into the ocean in Acapulco. While vacationing with some friends, his height as a function of time could be modeled by a function where x is the time in seconds and y is the height in feet. So the function's given to us three different ways there: function A, function B, and function C. They're all the same exact thing. They just appear differently. They're in different types of forms of our quadratic functions. We also have a picture off the side here that you can see when it comes to the functions over there on the left. So what is the maximum height that Jason was off the boat? How long did it take Jason to get to that height? Which function would best help you figure this out? So again, we have these three functions up here, and we're going to use them as we go along here. Here in this problem, right away, my eyes are drawn to the phrasing maximum height. When I see maximum, I'm thinking about the vertex. And it could be a minimum, but in this case, it's maximum vertex. So here in this problem, our vertex would lead us to need the vertex, obviously, and we need to find vertex form. So vertex form in this problem is in function C. And now we can take a look over there in the graph and hopefully kind of, sort of, maybe see the function, the vertex over there. But if we go to function C, it tells us the vertex right away. We know that our vertex in this problem, if we just look at C, would be the spot 0.5, comma, 30.25. And hopefully you can see well enough me typing on the screen here. So in this case, if I know x is the amount of time in seconds and y is the feet, we would know in this case that at 0.5 seconds after jumping, that we would be at a location of 30 point. I guess it's Jason. Jason's is at a spot 30.25 feet above the sea. All right. Question B says, how far off sea level is the boat? Which function would best help you figure this out? So we're talking about, obviously, the boat's not floating over top of the water. The boat is floating on top of the water. So we're asking how tall the boat is. So Jason, you would assume, would be at the top of the boat on the deck. He's jumping off here. So this is a situation where we need to figure out exactly the starting point that Jason is jumping off of. So since we need the starting point where Jason is jumping off, the phrasing here, starting point, or where he's jumping off, would lead us to need the y-intercept. And since we need the y-intercept in this problem, our best shot at getting that as quickly as possible would be function A, which we now know as standard form. So standard form here for function A. And in function A, without really doing too much math, we know that the y-intercept here would be 0, 30. 30 is the c value there. It is the only constant of the three terms in function A. So the y-intercept would be 0, 30. And what that does for us in this problem is tell us that the boat is 30 feet tall off of sea level. And that's where, obviously, there's a deck and Jason's jumping off of into the ocean while he's on vacation here.